Hey guys, let's look at lesson 3.5, which is converting to slope-intercept form. So last lesson, we looked at point-slope form, and the lesson before that, we looked at standard form. Now, we learned how to graph from each of those forms. Standard form, we can find our x-intercept and our y-intercept and graph them. And then point-slope form, we learned how to graph from a point and a slope. And at the end of the lesson, or the video, I hope you caught, where I told you now we can write it in slope-intercept form, since we found the y-intercept and we already knew the slope from the equation in point-slope form. Well, we can actually convert to slope-intercept form from point-slope and standard form if we want to, if necessary, right, for the equation, if it makes more sense to us. So in today's lesson, I'm going to kind of show you how you can do that if you prefer to graph from slope-intercept form, or if that helps you understand the problem a little bit better. So our goal is to be able to graph linear equations, and this time just by converting to this form. Now, if you feel good converting from the other, or graphing from the other two forms, then awesome, fantastic. But this is another way, and it might be better to graph from this form versus another form, depending on what information you are given. So our goal, if we can do this, then we'll be able to use the distributive property, which we looked at in Unit 1, right? That's multiplication when you see parentheses. Using inverse operations, we might have to rearrange the equation to solve for y, which we also did some in Unit 1. And then graphing from slope-intercept form, which we looked at the beginning of this unit. And then we can also check our work by graphing the equation on a calculator. We can actually check our work that way by plugging it in. And I will show you that in class, or your teacher will show you that in class. So just ask them. Okay, so our steps to converting to slope-intercept form, which if you forgot, is y equals mx plus b. One is to distribute if necessary. Which form would you have to distribute in? Point-slope form, right? That's the one that has m parentheses x minus x1. So that's when you would need to distribute if you're trying to go from point-slope form to slope-intercept form. Then we'll use inverse operations to solve for y. Neither of the equations, standard form or point-slope form, have y by themselves, which is what we need to get y equals mx plus b. So we'll have to use inverse operations to solve for y. Once we get y by itself, it's in slope-intercept form, right? Combine like terms on the other side of the equation, and then we can graph the equation, and we can check it on a calculator to make sure that we've graphed it the same. I like this little graphic over here on the right. It kind of gives us a picture of what each of these look like. All right, so it's this point-slope form where slope is m in the equation, and the point is x1, y1. Slope-intercept form, where slope is m and y-intercept is b. And then the standard form, where a, b, and c are integers, right? A and b are the rates, and c is going to be the total amount. So let's look at how we would convert from standard form to slope-intercept form in example number 1. So it asks us to graph the following function, 3x minus 4y equals 12. Now, we already know how to graph it, right, by finding my x-intercept and my y-intercept. But what if I want to convert it to slope-intercept form? Well, following my steps, the first thing I would need to do is to distribute if necessary. I don't see any parentheses in this equation, so I'm not going to need to do that. But I am going to have to do step number 2, which is using my inverse operations to solve for y. My goal is to get y by itself. Now, this might seem familiar. You might think, hey, wait a second. I think I've done something like this before. And you have. In Unit 1, Lesson 5, when we looked at literal equations, we did some solving for y. So hopefully, that jogs your memory a little bit, and we can help. We want to get y by itself, so I've boxed my y, including the sign in front of it, so that I can move everything away from it. That 3x needs to go to the other side of the equation if I want to get y equals mx plus b. So I'm going to use my inverse operations, and I'm going to subtract 3. Oh, I'm actually going to draw a line to help me remember where my equal sign is. So I'm going to subtract 3x from that side and subtract 3x from my right side. I remember that I cannot combine 12 and negative 3x minus 3x, right? 12 doesn't have an x, so I can't subtract it. So all I've basically done is rewritten my problem. So now I have negative 4y, because I remembered to bring my sign down, equals 12 minus 3x. You could also write this as negative 3x plus 12. Either way, whatever way makes sense for you, okay, it's going to end up being in slope-intercept form, whether it looks like y equals mx plus b, or it looks like y equals b plus mx. All right, so once I have negative 4 equals 12 minus 3x, all I need to do is get rid of that negative 4 times my y value. I just want 1. So I'm going to divide both sides of my equation by negative 4. When I do that, it's actually dividing my 12 and my negative 3x. So I'm just going to show that that's what I'm doing. All right, so my final equation then is the simplified is y equals, what's 12 divided by negative 4? It is negative 3. And negative 3x divided by negative 4, okay? Super important, guys, that you write down all of your steps and you write it clearly as possible so that you don't get that mixed up. It's a negative 3x divided by negative 4. That's going to end up being positive because it's a negative divided by a negative. We can't simplify 3/4 anymore, so I'm leaving it as a fraction because slope is easier as a fraction. So I end up with y equals negative 3 plus 3/4 x, which I can also write, if I wanted to write it in technically y equals mx plus b form, as y equals 3/4 x plus 3 since it was a positive 3. Or sorry, minus 3 since it was a negative 3. So now I have my slope and my y-intercept. Let's graph. My m is 3/4, and my b value is negative 3, which is at the point 0, negative 3. So I am going to plot my point right there, 0, negative 3. And I'm going to use my rise over run of 3/4 to graph another point. Up 3 over 1, 2, 3, 4. Okay, and I could do that again. I could go the other direction. I could go down 3 and then to the left 1, 2, 3, 4. Once you have at least 2 points, you can draw your straight line, put your arrows, and then you can identify the key features where I've gone through. I already have the y-intercept, and actually the first point I made was my x-intercept. So all I have to do is identify those points. We already know this is 0, negative 3, and my x-intercept is at 4, 0. Remember, that's also called a 0. So I can write that my 0 is 4 and copy down what my y-intercept and my x-intercept were. Okay, but what if it's from point-slope form? Point-slope form, following the steps, we must distribute first. So I'm going to draw my line to separate my two sides. I'm going to leave my y plus 2. There's no distribution I need to do over there. But I do need to distribute this 2 to my x and my 3. 2 times x is 2x. 2 times positive 3 is positive 6. Now that I've done that, I need to get y by itself by using inverse operations. The only thing that's on the same side as my y is that positive 2. So I need to subtract 2 from both sides. Subtract it from the like terms, so I'm subtracting from that positive 6. Draw my little line to show my equal. 2 minus 2 is 0, so I just have y equals 2x. 6 minus 2 is 4. And there I am. Y equals 2x plus 4. So in this problem, my m is 2 and my y-intercept is 4. Or 0, 4. So I'm going to go and plot that 0, 4 and use my slope to graph some more points. Up 2 over 1, up 2 over 1. Or I could go down 2 to the left 1, so to the right. Draw my line and my arrows, and then identify my key features. I have my y-intercept already, and here I can see this is where my line goes through the x-axis. So my y-intercept, we already know, was 0, 4, and my x-intercept looks to be at negative 2, 0. So it has a 0 of negative 2. All right, there you have it. So following those steps, we're just simply getting y by itself. That might mean we have to distribute first, okay? But we can get each equation to have y by itself and solve for it. Okay, good luck practicing, and let your teacher know if you have any questions.